Bismillahirrahmanirrahim. Assalamu alaikum students. How are you all? Hopefully you all are fine, enjoying good health. Welcome to another lecture of physics. Students, in previous lecture we have discussed Newton's second law of motion, and in Newton's second law you have studied that whenever we apply the force, acceleration is produced. The direction of force and acceleration should be same, and the magnitude of the acceleration is directly proportional to the applied force, and the magnitude of the acceleration is inversely proportional to the mass. So that was all about the statement of Newton's second law. We derive a relation that was F is equals to ma, and then we discuss the unit of force, that was Newton, and we see that 1 Newton is equals to 1 kg into 1 meter per second square. Now students, we are going to discuss question number 8 and 9. Question number 8 is about the difference between mass and weight, and question number 9 is Newton's third law of motion. The difference between mass and weight is necessary for the understanding of Newton's third law. That's why we study the difference between mass and weight with Newton's third law. So students, you can see these two questions from your notes. On your notes, this is question number 8 and question number 9. So students, let's start our lecture. Firstly, we discuss the difference between mass and weight. Students, usually we see that there is a misconception that mass and weight both are the same quantities, both are same. But mass and weight are not the same thing. There is a difference between mass and weight. For example, when someone asks you, what is your weight? Then what you will say? My weight is 75 kgs, 60 kgs or 40 kgs. But we also know that kilogram is the unit of mass and the unit of weight is Newton. It means that mass and weight both are not the same things. There is a difference between mass and weight. Students, mass is usually written with small m, and it is the quantity of matter possessed by the body. And quantity means the building block of that material. For example, this block is made up of 100 atoms or elements or molecules. So I say that those 100 atoms, molecules or elements are the building block of this matter. So what is the quantity of matter here? 100. 100 elements, 100 molecules or 100 atoms. So students, the quantity with which that matter is made up of is basically the mass of that body. Now students, what is weight? Weight is another thing. For example, when you stand on the earth or a person is standing on the earth, the force with which the earth is attracting that person towards its center will be its weight. So weight of the body is the force acting on it. So what we understand from here, that weight is a force. So what is the unit of force? Newton. And previously I told you that the unit of mass is kg. So from here you can easily distinguish that mass and weight are the two different things. Hopefully it is clear. Students, mass is a constant quantity and it will never change by change of place. For example, if this block is 5 kg, it will be 5 kg anywhere. But we have seen that things become lighter when we move to the other planets. For example, we have seen that when people move to the moon, then they become lighter. Why? Because the value of gravity on the moon is less as compared to the earth. Things are attracted with less force on the moon, so things will become lighter, there will be less force on them. So, what we understand that why the things are lighter on the other planets, because the value of the gravity, less force is applied on them. Mass will never change with the change of place, but weight will change with the change in the value of gravity. Another thing about them is that mass is a scalar quantity. Why? Because mass is not having any direction, and weight is a vector quantity. Definitely weight is a force and force is having a direction. So, we will say that weight is a vector quantity. You can also see, students, there is a formula W is equals to mg. This formula is for finding out the weight. So, here you can see that weight is depending upon the value of gravity. Now, students, we will discuss Newton's third law of motion. Statement of Newton's third law is every action has an equal but opposite reaction. Let us suppose there is a body A and it exerts a force on another body, that is B. The body B will also react against this force and exert a force on body A. The force which is exerted by the first body, the body A, is called the action force, and in the reaction the force which is applied by the body B is called the reaction force. So, hopefully you understand what is action and the reaction. The force which is applied by the first body is the action, and in the reaction the force which is applied by the second body is called the reaction force. Another thing, students, that magnitude of both the forces should be same. For example, the first body is applying force of 5 Newton, the reaction force should also be of 5 Newton. So, action and reaction force both must have equal magnitude, but their direction should be opposite. For example, if one object is applying the force forward, the second one force should be backward. If one object is applying the force in east direction, the second one should apply the force in the west direction. So, their direction should be opposite. This is the first example. In this example, you can see that force is applying the force on the ground, and in the reaction the ground pushes the cart forward. In this way the horse can move forward. So, this is the first example of Newton's third law. Rockets and jet engines also work on the principle of Newton's third law. The rocket and jet engine are moving in the upward direction, this is the action, and the exhaust gases are applying the force in the downward direction. In this way the equal and opposite forces are balanced, and Newton's third law is applicable here. Next example is a book lying on the table. In this example, students, the book is applying an action force on the table, and the table is providing a reaction force. The magnitude of both the forces are same. For example, if book is applying 5 Newton force on the table, the reaction force by the table is also 5 Newton, and the book is applying the force in the downward direction and the reaction of the table is in the upward direction. So, a book lying on the table is also the example of Newton's third law. Then, students, there is a question that if action and reaction forces are equal in magnitude and both are having the different directions, then why these two forces do not cancel each other effect? The answer of this question is, as the action and reaction forces are applied on two different objects, action force is applied on different object and reaction force is applied on different object. So, these two forces do not cancel each other effect. There is another question, students, that how are we able to walk? The answer of this question is we walk forward because when we push the ground with our feet in the backward direction, and as a result the ground pushes us in the forward direction. So when we walk forward, when one foot pushes backward against the ground pushes forward on that foot. So here you can also see that action and reaction forces both are applied onto different objects. So we can also say that here both the forces do not cancel each other effect. Next question, what makes a car go forward? The answer of this question is the ground pushes the tires of the car in the backward direction, and in return, as a reaction, the acceleration is produced in the car and the car will move forward. So here you see that with the help of action and reaction force of equal magnitude and opposite direction, the car will move forward. There is also a question for you students. You have to write its answer on your notebooks, that how can you explain the motion of the man in the image according to Newton's third law. You have to explain motion of this person which is shown in the figure, and how you have to write its answer on your registers. Students, that was all about today's lecture. Hopefully you all well understood question number 8 and 9. Students, you have to learn both the questions from your notes, and if there is a need to write these questions, you will also write them, and you will there will be a test in the future from question number 8 and 9, that is difference between mass and weight and Newton's third law. So that was all about today's lecture. Have a good time, have blessed days. Allah Hafiz.